So the part which was just remaining in the case of quantum physics was the wave particle duality, or in short, we can also say about the de Broglie's wavelength, or in second way, we can also say that any of the atomic particle being a particle, it also exhibit a wave nature. And how we are going to come up with this fact that any particle is exhibiting a wave nature is due to the phenomena of diffraction, because we know, and if any thing is a wave, it is either going to diffract or is going to interfere. So likewise, Louis de Broglie discovered that matter, like for instance, if we talk about electrons, it also behave as a wave. And if we need to prove that anything is acting as a wave, it means that it is going to diffract or it is going to interfere, right? It means that it is going to be have a formation of the diffraction pattern or it is going to have an interference pattern. So experiments show that diffraction pattern is being produced when a beam of electron is directed at a thin graphite film. So here at the bottom, you can see one diagram. Let's say there is one electron gun. This electron gun is emitting the electrons. So these small dots are representing the electrons, the stream of electrons. And these stream of electrons are projected on a thin graphite film. Like there is a metal bar which is made up of what? It is made up of graphite film. So when these electrons are going to hit the graphite film, what is being observed that electrons begins to show the wave property. Like they begin to move in the form of wave and forming some diffraction patterns. So when they were being observed on a thin filament screen, so it was observed that there was the formation, the electrons were moving in concentric circles. If the initial accelerating voltage, like the voltage which was given to the electron to accelerate the electrons, if the initial accelerating voltage is low, the gap between the concentric circle is high. And if the accelerating voltage is high, the gap between the concentric circle appears to be less. So this behavior of forming the concentric rings by the electrons represent that electron also can be stated that it exhibit the wave nature. So this was the wave particle duality principle, that any of the matter can exhibit a wave nature, plus it can exhibit the particulate nature. So electron being a particle, it is considered that electron is also exhibiting the wave nature. And how it has been proven? It has been proven that electrons, a stream of electrons, when they are emitted from the electron gun, when they hit the thin graphite film, they begin to diffract, they begin to spread out, they begin to form the concentric circles. So this represents the diffraction phenomena. The electrons, the stream of electrons begins to spread out. So this behavior for the stream of electrons can be considered a wave nature. And if the initial accelerating voltage is low, the gap between the circles, like we can witness here, the gap between the circle is high. And if the initial accelerating voltage is high, the gap between the concentric circle is considered as less. So this observation is generally being asked in the paper. And why these gaps are more and less, so we are just going to investigate it or find its reason in a while. So yes, student, is this understandable about the wave particle duality principle? That how any of the particle is exhibiting the dual nature? Yes, please speak up. Are you with me?
Yes, sir.
Rest of the kids, please speak up.
Yes, sir.
Okay. So what is happening? What's next is happening in it. So let's move on. So here is the theory being written about it. So when electrons get passed through the diffraction grating, right? So what is the meaning of diffraction grating? This thin graphite film will be acting as a diffraction grating. You would be knowing about the diffraction grating. It's any of the plate which is having multiple slits on it, which is having multiple number of slits on it, and when some light passes through it, so it shows the pattern of the diffraction, and later those diffracted the multiple diffracted rays, they actually meet at one point and they form the interference behavior, right? So similar happens here, that these electrons are going to hit, and after hitting the diffraction, they are going to spread out, and when they'll be spreading out, so what next will happen? The concentric circles are going to be formed, and these concentric rings or circles are actually going to show the diffraction pattern. So when electrons were passed through a diffraction they find electrons diffracted and interfered, forming rings on the fluorescent screen. So you must be knowing about this phenomena, that when electrons were passed through a diffraction grating made of graphite, the electrons diffracted and interfered, forming rings on the fluorescent screen. So we can say that, let's say, work done by the accelerating voltage. What is this accelerating voltage? Which makes the electron to move after being produced from the electron gun. तो ये वो वोल्टेज होती है इलेक्ट्रॉन गन को दी जाती है जो इलेक्ट्रॉन को आगे एक्सेलरेट करवाएगा till the graphite film. And from the formula of voltage, we know what's the formula of basic formula of voltage or potential difference. It is work done per unit charge. So work done per unit charge can be written in what way? It can be written as work done is equals to voltage into charge. So from here, this formula came into being voltage into charge, and this is equals to gain in kinetic energy. So you must be knowing we learned one formula of the kinetic energy in terms of momentum. So we know V into Q is equals to momentum square over 2m. So from this, momentum can be stated as what? Momentum is equals to under root 2m VQ. So in exam, it is being generally asked to derive this formula. So you must be knowing if an electron is accelerating, how to derive the formula as momentum is equals to under root 2 mvq. So m stands for mass of electron, v stands for the voltage, accelerated voltage, q stands for the charge. So under root 2 mvq will be equals to p, and p is momentum. So from here we can see, we know the diffraction grating formula, d sine theta is equals to n lambda. If wavelength is less, so diffraction will be less. If wavelength is high, diffraction will be high. So from here we can see few things. So if the accelerated voltage is increased, the momentum of the electron is going to get increased. And if the momentum is going to increase, the wavelength will be decreasing. The wavelength will be decreasing. If the momentum of electron increases, the wavelength will decrease. And when the wavelength decreases, from here we can see, if the wavelength decreases, there is going to be less diffraction. Less diffraction means the rings are closer. So this is the reason why the rings in the previous case at a high accelerating voltage are closer to one another. So if the initial accelerating voltage is high, the momentum of electron will be increased, the wavelength will be less because there will be more electrons near to one another. So wavelength causing will be less. When the wavelength will be less, as per the diffraction grating equation, we can say less diffraction means the rings are closer to one another and the radius of the ring decreases. And likewise, opposite also holds for this. So if the accelerating voltage is decreased, momentum of electron decreased, so the wavelength will increase and there will be more diffraction. More diffraction means rings get away from each other and the radius of the rings is going to increase. So inverse of this also happens. So this is the answer of a question that why does the rings of the diffraction are widely spaced or why the rings of the diffraction are closely spaced. So as per all of these points, you can answer out the respective question. So what was being observed? A larger accelerating voltage reduces the diameter and lower accelerating voltage increases the diameter of the rings. Yes, student, is this understandable? Hello, please
Yes,
speak
sir.
up. Yes, other student, please can you just comment? Iman, Hamid, Javeria, Myra, Usman, Shayan. Is this concept of diffraction of
Yes,
electron
sir.
is understandable?
Yes, sir.
All right. Shall I move onwards?
Yes, sir.
Okay, so this whole is just describing what is happening in the case of de Broglie. So the wavelength of this particle or electron, that wavelength of the particle will be called as de Broglie's wavelength. So de Broglie's proposed that electrons travel through space as a wave. He just gave this impression, he just proposed this idea that electron is just not only a particle, but it can also act as a behave, which was further a foundation of the quantum physics. So this would explain why they can exhibit behavior such as diffraction. So he therefore suggested that electrons must also hold wave properties such as wavelength. तो उसने कहा कि अगर इलेक्ट्रॉन वेव्स बन रही हैं या वेव्स का पैटर्न रख रही है तो हमें पता है कोई भी चीज जब वेव होती है so it exhibit one nature which is called as wave length. So however, he realized all particles can show wave-like properties, not just electrons. And this wavelength can be defined as de Broglie's wavelength. So the wavelength associated to the moving particle, when any particle is moving, उसकी जो wavelength होगी, that wavelength will be called as de Broglie's wavelength. उसकी wavelength जो होगी, that will be called as de Broglie's wavelength. The wavelength associated with the moving particle is called as de Broglie wavelength. So let's find out the relation for the de Broglie's wavelength. We know the formula from the momentum of a particle. We know that momentum of a particle we studied earlier, revised earlier as well. It is equals to Planck's constant divided by wavelength. And if we need to find out the wavelength, it can be made as a subject and can be written as lambda is equals to h over p. Further, we know momentum is written as mass into velocity, the basic formula of momentum, which is lambda is equals to h over mv. Moreover, using the kinetic energy relation and momentum relation, we know kinetic energy is equals to half mv square over 2, plus we also know from the formula of momentum that p is equals to mv, v is equals to momentum over mass. So this v will be replaced instead of v square. So when we are going to take the square of this p over m, so it will becomes what? P square over m square. So this m over m square will cancel out, and our energy will be remaining as what? Momentum square over twice of mass. Further, we can make momentum as a subject. Momentum is equals to under root 2 me. So momentum is equals to under root 2 me. So from here, we can find out the lambda relation in terms of energy. We know lambda was equals to what? Lambda was equals to h over momentum. And instead of momentum, we can write down under root 2 me. So wavelength lambda is equivalent to h divided by 2 me. So this relation is generally being asked from you people to derive it in your exam. That derive this equation is called as de Broglie's wavelength. This equation is called as de Broglie wavelength. This is called as de Broglie's wavelength. And it is given from the formula lambda is equals to h over p, lambda is equals to h over mv, and kinetic energy is half mv square, which can be stated or equated as momentum square over twice of mass. We know momentum is equals to under root 2 me, and when this momentum is being replaced in the first equation, so lambda will be equals to Planck's constant divided by under root 2 me. So this equation is known as the Broglie's wavelength. Yes, student, tell me, is this understandable?
Yes, sir.
जी प्लीज पिक अप हमारा सिर्फ 1 मिनट रह गया और आई गेस वी आर जस्ट अबाउट टू नियर टू द एंड एज वेल
Yes,
चलो
sir.
मैं यस शैल आई मूव ऑन
Yes.
ओके नेक्स्ट थिंग इज okay this is the last part how to apply the de Broglie's equation formula, right? So there is a proton electron, they are accelerated from rest through the same potential difference. It says determine the ratio of de Broglie's wavelength of proton to the electron. So we know what is the formula of the wavelength. It is h over under root 2 me. And from here we know that wavelength is inversely proportional to the under root of masses. So to find out the ratio of the wavelength for proton to electron, we are going to divide the under root of mass of electron to the mass of proton. So we know what is the mass of proton, 1.6 into 10 power minus 27. And what is the mass of electron? 9.11 into 10 power minus 31. So in an under root, we are going to divide both the masses and we are going to get the ratio. So as it is the ratio between same quantity, so there is going to be no units. So this will be equals to 2.3 into 10 power minus 2.